can't see many of you in the lectures today. You still sleeping or what? All right, if you've done quiz 6, can you hand it to me at the end of this class? Hello guys. If you've done quiz number 6, please hand it to me at the end of this class. And one other announcement is, if you haven't been to any of the example classes this week, there are two example classes this afternoon, from 1 to 2 and 2 to 3. So please come to one of those this afternoon, all right? That is, if you haven't been to any this week. Right? Now, I will start by, as usual, summarizing what I did on Monday this week. On Monday, I talked about maximum likelihood estimation. So this is the procedure to follow. There's a 4-step procedure. This is the procedure to follow if you have continuous data. So the first step is to write the likelihood function. The second step is to take the log. The third step is to take the derivative of the log likelihood with respect to the parameter and set to 0. And let theta hat denote the solution of equation star. And step number 4 is to show that the second order derivative at theta hat is negative. And if it is negative, then theta hat is an MLE. So it's a simple procedure, right? I mean, the purpose of maximum likelihood is to derive or is to construct point estimators. I mean, we talked about point estimators last week. And this is one method for constructing point estimators. There are other methods, but I will not talk about them in this course. I mean, maybe in year 2 or year 3, you will learn about other methods for constructing estimators, right? So this is for continuous data. And this is for discrete data. So if your data is discrete, come on guys, please listen to me. If your data is discrete, then the procedure for finding MLE is similar, but there are some slight changes because you'll be working with the PMF and not the PDF, right? So those are the changes. Then I said I was going to do, I showed you some elementary identities involving sums and products. So these are 3 identities involving sums, right? And these are 5 identities involving products, right? I mean, I know for many of you, maybe most of you, this could seem trivial, but I mean, I taught courses in the second year for a long time, and I see many students not knowing these identities, right? So it's really important that you do remember these identities, right? Right, then I said I was going to do 10 examples. I started with example 1, where your data is from an exponential distribution. And in this case, the MLE turns out to be 1 divided by the sample mean. Right? Example 2, here you have data from a Poisson distribution. And in this case, the MLE turns out to be the sample mean. That's example 2. Example 3, so data is from a normal distribution with mean equal to theta and variance equal to 1. In this case, the estimator for theta is a sample mean. That's example 3 one more time. Example 4. Example 4 is, here you have data from a normal distribution with zero mean and variance theta squared. And in this case, the estimate for theta turns out to be the square root of 1 over n times the sum of xi squared. And that's the same. And example 5, this is example 5. I ran out of time. I ran out of time to do example 5, so I asked you guys to do it. Did you have time to do it? Yes? No? Come on, guys. I mean, let me tell you something. I gave this as a test question. I gave this as a problem for second year students about a long time, about 5 or 6 years ago, and none of them were able to get the correct answer. I mean, which is kind of shocking, because this is kind of stuff you do in the first year, not in the second year, right? Okay, so let me show you how to do it. If you haven't done it, I mean, if you've done it already, that's great. If you've already done it, that's great. All right, the first step is too cold outside, so I've got the jacket on. So the first step is to write down the likelihood function, right? So So the likelihood function, as you know, is the product of the density function. And the density function is this, right? So if you simplify this, right, this is what you get, right? Are you with me, guys? Okay. Now the second step is to take the log of the likelihood function. So you take log right? This is what you get, okay? Right, now, in the next step, what I'm going to do is I'm going to expand the brackets, okay? So if you expand the brackets, this is what you get. You get get this. You with me? All right. Now I'm going to take the sum inside the brackets. right? And also divide by 2 theta squared. So it's going to be yeah. Is that right? You see what I've done? I have taken the sum inside the open brackets and divide by minus 2 theta squared. So you get these three terms. Correct me if I'm wrong. Okay. Right. So let me put this over here so all of you can see what I've written. Now step number 3. Step number 3 is to differentiate the log likelihood with respect to theta, right? So if you do that, you get minus n over theta plus 1 over theta cubed right, and minus okay, this is what you get. Once again, if I made any mistakes, let me know, right? So this is the derivative with respect to theta. Now I'm going to set this to 0 and try to solve for theta, right? So this implies that okay. All right. Now, what kind of equation is this? I mean, do you recognize this equation? It's a quadratic equation. I mean, you guys learned that in the nursery, right? Yeah. So I'm just kidding, but then if you have something like a theta squared plus b theta plus c equal to 0, right? What's the solution for theta? Theta is equal to minus b plus or minus b squared minus 4ac divided by 2a. Yeah? I mean, you must have learned this when you're in the nursery or something. Yeah? Okay, so it's a quadratic equation. So now if you use this formula, you see that theta, or theta hat, say, theta hat is the solution, right? Will be minus b, which is sum of xi
plus or minus b squared, which is this is b squared minus 4ac, which is 4 wait a minute, this is b squared minus 4 ac, which is 4 times a is n and c is divided by 2a, which is minus 2a. Okay, is that right? So this is the solution that you're getting. So it's minus b plus or minus b squared minus 4ac, which is minus 4ac. So it's going to be minus 4n times this, gives you this. Now there are two roots here. Which of them is valid and why? I mean, you have plus or minus, right? That means there are two roots for theta hat. Which remember, theta represents standard deviation. So it must be a positive number. Which of them is a positive? Which of the two roots is a positive number? Yeah, exactly. The one with the minus, right? So this implies that theta hat is the sum of xi, I from 1 to n, minus Are you guys with me or lost? Are you okay? All right. So this is the valid solution of the equation because theta represents the standard deviation, right? Okay. Now we are not done yet because we need to show that the second order derivative is negative. Right? Okay. So to do that, you need to Are you guys okay? Yeah? You need to find the second order derivative of the log likelihood, which is going to be the following. It's going to be n over theta squared minus 3 over theta 4 and plus 2 over theta cubed. Alright, so this is this, and we need to show that this, whatever we have here is a negative number. I know it doesn't look trivial, but if you do some, alright, okay, let me show you how to do it. Alright, so you can write this as follows. Right? Okay, I've factored out theta power 4 outside. So this is what you get. Now we need to show that what we have here is a negative number. Okay? So the way you can do this is as follows. Now let me call this let me call this equation 1, okay? Okay, from equation 1, right, from equation 1, you can see that right, okay, all right, and therefore, yeah, okay. Now let me call this equation 2. Let me call this one equation 3. Right? Let me put this in a box. You see a lot of boxes in this course, so okay. Now you should substitute 3 into 2, right? So what I'm going to do is I'm going to replace 2 theta sum of xi by the right hand side, okay? You will get this. Right? This is what you get, right? Now what you have here is a negative number because right, and this is clearly what you have is clearly a negative number, right? Are you with me or not? Are you guys, is there anybody who got lost or not? Right, so therefore we have shown, hence, all right, so we have found the MLE for theta, right? I know this is not a trivial problem, but you can see that it's not trivial, but the concepts I have used are pretty basic. I mean, quadratic equation is something you learn in, I don't know when you learn, I don't know, I guess in your A level or you learn quadratic equations, right? So it's an interesting problem, but all right, so that's example 5. Next one, example 6. All right. Suppose I mean, if I know this is a little bit detailed, but if anything is not clear, please see me after the lectures, right? You know when to see me. I mean, you can contact me 24/7 by email or Zoom, right? All right, this is example 6. So suppose you have a data x from a binomial distribution and you want to find the MLE of P. So the first step is to write down the likelihood function. Now, because here we only have one data point, x, it's not like x1 to xn. So in this case, this is simply the probability that x equal to little x, which is n choose p, sorry, n choose x, or n choose x, p to the power x, 1 minus p. I'm sure all of you know this. Right? This is the probability mass function of the binomial. Here we do not have a product sign because we only have one data. When you have one data point, the likelihood is the same as the PDF or the PMF. In this case, the PMF, right? Right, then you take the log of the likelihood function. This is step 2. Step 3 is to find the derivative with respect to p. So you get x divided by p. Set this to 0 and solve for p. You get so alright, so p hat is x divided by m, right? And step 4 is to take the second order derivative, which is and this is clearly negative. I mean, the second order derivative is clearly negative. So hence okay. So this example is relatively straightforward compared to the previous one. Okay. All right. The next so is example 6. Now, example 7. I said I'm going to do 10 examples. I mean, the reason I do so many examples is to give you, give you the experience, and give you the. Mathematics is you learn by examples, right? So I hope all the examples I'm doing and I'll be doing in the future will help you to learn this course better. All right? Okay. Next one, example 7. You okay, guys? Any questions so far? You listen please. Right here, example 7, we have a random sample from a geometric distribution with parameter p. We want to find the MLE of p. Alright, the first thing to do is to write down the likelihood function, which in this case, because you have n data points, you have to take the product. The product I from 1 to n. Now, do you guys remember the PMF of the geometric? What's that? Is p times 1 minus p xi minus 1. Right? This is the probability mass function of the geometry. Right? Okay, so if you do this product, you get p power n okay guys. Now you should take the sum of this. You guys okay? You should take the sum of this. You get the sum of xi, yeah, I from 1 to n. And the sum of 1 is n. Okay? Okay? That's part 1. Part 2 is to take the log of the likelihood. Yeah? So log of this, you get n times log of p plus right? So that's the log of the likelihood, right? Part 3 is to take the derivative with respect to p. Right? And you set this to 0, okay, and solve for p. So if you do that, you get okay, and if you solve this equation for p, you get the following. You get p, sorry, excuse me, you get p hat equal to n divided by the sum of xi. Which is the same as 1 divided by the sample mean. Alright, we are not done yet because we need to show that the second order derivative is negative, right? So that's what I'm going to do now. So part 4. Come on guys, please listen. somebody tell me why this is negative. Why is this negative? Why should this be negative? I mean, there's a negative sign here and a negative sign here. What do you know about this? Huh? No. Well, okay. Let me show you. What do you know about xi? Xi is a data from the geometric distribution, right? This is what I said here. Xi is from a geometric distribution. So xi by definition must be greater than or equal to 1. Okay? And therefore, if you sum xi, it must be greater than or equal to right? And this implies that the right? You follow what I'm saying, guys? So let me put this in a box. Lots of boxes. All right? Put this in a box. Right? So what I've shown here is that this part here is always non-negative, right? And therefore, it must be negative, right? That thing here, right? Hence, right? This is here. Okay. Do you guys follow this or not? Yes. Yes, sir. You have a question? You mean this one? You should differentiate. Yeah, this line here. No, sir. I think this is correct, because when you differentiate this with respect to p, you get a minus minus. You get a minus minus, so which is plus. So you have to keep the negative sign. Just think about it. I think this minus is correct according to my. I mean, if somebody doubts it, you can talk to me outside. You can talk to me after the class. I mean, yeah. All right. So this is example 7. Now, example 8 is gonna be. I mean, I'm sure you guys are learning calculus, so you should know it better than me. I mean, so anyway, example 8. It seems I may not have time to do all 10 examples, but Okay, so here we have a random sample from this distribution. By the way, it's known as the Pareto. If you don't know what's the name of this is known as the Pareto distribution, all right? So it's known as the Pareto distribution, guys, right? So the first thing to do, come on guys, please listen. Now, the first thing to do is to write down the likelihood function of A, because we are assuming the parameter K is known. So only A is, we need to estimate only A, not K, all right? So it's gonna be the product of the density function. What's the density? Okay, what you're given is the CDF. So to find the density function, you need to differentiate this, right? Okay, so it's going to be A so you see what I got here is the derivative of the CDF, right? Okay, so this is going to be okay, and you can write this further as this. Okay, so this is the likelihood function. Step 2 is to take the log. So you get n log A Now remember, the log of a product is the sum of the logs. That's an identity I gave you on Monday this week. Right? And step 3 is to differentiate the log likelihood with respect to A. So you get n divided by A plus n log K minus the sum of x, sum of log of xi. Okay? Now you set this to 0 and solve for A, you get A hat equal to the following. N all right, this is the solution for A. Right now, to make sure that this is an MLE, we need to differentiate one more time. Okay? So you should differentiate one more time with respect to A. This is what you get, right? And clearly this is a negative number, right? Okay, so hence, similarly. Okay. Are you guys okay with this? This is an easy one, right? Right. Any questions so far? No. Yeah. Right. Now, this is what example 8. I would just stop with example 9 and one short of my target because I think I'm running out of time to do 10 examples. So I hope you forgive me for not doing 10. Okay. Okay. Maybe. So example 9. Um, Alright, the first thing to do is to write down this ln. I'm sure all of you know what ln means. ln means log normal, right? Okay, so the log normal will be the product right? This is the log likelihood. If you should simplify this, you get right? This is what you get, right? That's step 1. Step 2 to take the log likelihood. Right? This is step 2. Shh, just listen, guys. Are you in a hurry to go home? I mean, come on. Okay, step 3 is to find the derivative. So you get minus a half times there would be a 2 here, sorry, 2 times this times minus 1. Okay. Now if you simplify this, guys, you get the sum of log of xi, that's one term, minus n theta. Set this to 0, you get theta hat equal to 1 over n right. Now that's step 3. Now step 4, thank you for your patience. Step 4 is is to find the second order derivative, which is minus n, which is clearly negative. Hence, is all right. Next week we will talk about. Next week we will talk about two-parameter maximum likelihood estimation. I mean, so far we only talked about one parameter in every example. But next week we will talk about what happens when you have two parameters that are unknown. Okay? All right, guys. If you've done quiz 6, can you give it to me now, please? And also, there are 2 example tutorials this afternoon. If you haven't been to any of them this week, please come to those. All right? Thank you, guys. Natural log, yeah. Huh? Natural log, yeah. LOG is natural log. They're both natural. I don't distinguish between LOG and LN. I mean the same thing. Yeah. It's 1 to 2 and 2 to 3. Yeah. Hello, sir.
Do you know when you've got, in our notes, you say take the partial derivative here,
Yeah.
and you just put the normal, it's when you just like, as the partial derivative.
No, it doesn't matter because you only have one parameter.
But when you've got multiple ones.
When you have one parameter, the partial derivative is the same as the ordinary derivative.
But next week we're going to do multiple derivatives that will make
Yeah. When you have more than one parameter, they are different. Yeah.
Okay.
Yeah. Hello. Log normal, yeah. It's in the list of distributions I gave you in the first day. You see, I gave you a handout with distributions. It's there. Log normal, yeah. Thank you.
Hi, this is Chris 7.
Thank you. Hello, guys.
Hi.
Thank you. Thank you. Hello. You okay? Thank you, guys.
Thank you.
Thank you.
I mean, I suppose
Hello. Thank you. Hello, sir. How are you? Where's your friend?
This is my friend.
Ah, okay.
We have a question. Do you have any book of exercises?
on what?
Everything, because when you do everything here, it looks so hard, and you just need more practice.
Come on, I've done 10 examples. That's enough.
It's enough to see how you do, but we can't copy it
Maybe
ourselves.
to practice at home.
Yeah, but you can do the ones in the tutorials. The ones in the tutorials. Also the ones in the past
Just a
exam.
little. Two little
more
exercises. We want more. Yeah.
Yeah, but you can look in the past exam papers which are online. You know the past exam papers.
But if we do them, then we will have nothing to do in the break before.
Okay, I'll find some problems for you.
Okay.
Okay. Thank you, sir. Thank you. Hello, how are you? You have a question?
Yeah, do you know the last example you're going to do? Can you write it down so I can do it?
Which one?
The 10th one that you're going to do.
Ah, the 10th one. Okay, I'll do it. Give me a sec. Thank you. Thank you, guys. You solved it.
Yeah.
You said you had a problem.
Yeah, I figured it out.
Okay, good. Yeah. Okay, let me write it down. Do you have time? Yes. Maybe that's okay. It's like this. You have x. So how do you find this course? Okay.
Yeah, I think it's good.
If you have any questions, just feel free to see me.